All right, welcome back. It's good to see you all. And I thank you for your cooperation and your willingness to kind of do the test one day earlier. But I think you'll see today should be fairly quick. We'll finish up uh, 8.1.2.3, which is really all one homework. There's 16 questions in there. So we'll get to this part. And then the last section is there'll be 6 questions in the homework about drawing marbles out of bags, and we'll do an example on drawing marbles out of bags, and you'll see it just kind of puts everything together that we've done. So we'll have that down. Um, okay, we'll move into this, and then I'll show what I've got going as far as additional resources. Okay, so the other thing we need when we're counting, remember that we talked about this when we were back in this, just talking about sets, that if we take the union of 2 sets, that if there's an overlap, if we count everything in one set and everything in the other set and add them together, there's this overlap that's getting counted twice, right? Because there's stuff in the middle. So we come up with these, what's going on? So we want the union of 2 events. So maybe the event is I go order coffee and I get a cinnamon roll. Okay, so those are 2 different things. I'm taking the union, or I guess I should say I order coffee or I get a cinnamon roll includes and I get a cinnamon roll, and all these, so it's inclusive completely. So if we happen to know the probability of A and B, we can't just add them together because there's this overlap area, right? And so to get the actual, since that's getting counted twice, we have to, if we just know the probabilities of A and B, getting coffee, getting a cinnamon roll, we have to subtract off that overlap. So we need that additional piece of information, because if I've got a 60% chance of getting a coffee and a 60% chance of getting a cinnamon roll, that would mean I'd have a 120% chance of getting both, right? Or getting one or the other. That doesn't make sense. So there must be some overlap in there, and that's what we'll do. So something like this. The probability of, let's see, what is this? This must be the probability. Well, I don't know what it's the probability of, but I guess the event A is we roll a 2, 5, or a 4. Probability of B is we roll a 6, a 2, or a 4. And again, if we say what's the probability of A or B, union, right? If we count this middle region twice, then we're going to come up with too much. We would come up with 110%, but that's why we subtract off that overlap. Okay, so sometimes the way they give us the information, they're going to give us the probability as a decimal. We won't necessarily get to count. And so this is where we sort of have to use this formula, because we just have to remember to subtract off that overlap. But if you kind of think of it pictorially, it sort of makes sense that you're counting something twice, rather than just trying to memorize a formula and say, why am I subtracting this? I don't know. It's because there's an overlap. Okay, and that's called the addition principle. There's also, I mean, if you do a little algebra, right, you could add this to both sides and bring this over. So if we knew what the union was and we knew A and B, we could figure out what the intersection is. So we can do some algebra if we need to on these types of problems. Okay, and so again, here's just a visualization. We've got 2 potential events that could happen. They're probabilities, but there's a possibility they could happen together. Now, I deleted a lot of slides that talks about being mutually exclusive, so they're separate. There is no overlap. Would it make sense if there's no overlap? We don't have to subtract anything. I just left it off because what you're subtracting is 0. So don't, it's kind of, why do we have to spend 10 slides to talk about why we're not subtracting anything? Let's just leave this formula and say, well, if there's no overlap, it's 0. We subtract 0. So that's all we really need to talk about that one. So even if they're separate, we just look for what is the intersection. It rains and it doesn't rain. There's no intersection there, right? It's one or the other. Okay, so here's one that's similar to what you'll see on the exam review. You'll see some of these, something like this in the homework as well. So use this given information to find the probability of A union B. Now remember, that's usually what we're trying to do, the A or B. We would add the 2 together and subtract off the intersection, but they're giving us a little bit different. they're actually giving us the intersection here. Oh wait, no, I guess that's what we do. It's the next one that's backwards. So, so we've got the probability of A. Oh wait, what? Sorry, they gave us a probability of A union B is 0.7, so the total probability. A is 0.35, and there's an overlap of 0.15. So one way of doing this is thinking, okay, there's this Venn diagram here. And when we draw, and one of these is A, and one is B. We know that these two circles together are 70% of the area. And then I guess there's always sort of this sort of rectangle is the universe of what could happen. So if we know that there's a 0.7 chance, a 70% chance that A or B could happen, what's the chance that A or B does not happen? 0.7 minus 1, 0.3, right? Okay, so we don't have to do all of this, but I'm just, getting understanding. So we know there's a 0.3 outside of the circles. We know that the total inside these two circles is 0.7. But when we start to sort of construct this, what we want to do is if we can start in the middle, the overlap, we know that this middle little football shape region, is 0.15 or 15%. I like to work in percentages because decimals so often get lost. So there's 0.15 there. How much in total is in A? 0.35. So that means that actually over in this region that's outside the football, there must be 0.35 minus 0.15, 35% minus 15 is 20%. Right? Because those two would add together to give us our 35%. So how much is just in B? Well, we could kind of, and again, you might have done this quicker. The rest in B is going to be this 0.15. What's in this region? It's 0.7 minus 0.35. Okay, which is going to give us what? 0.35. So that's the total in B, right? No, that's not the. That's this region here, 0.35. So what's the total in B? 0.35 plus 0.15. Both regions. So this is a visual way. I'm going to go back and do it with the formula because some of us, one way works better than the other. One makes more sense. What did I say? That's 4.4 plus 0.5. 0.5, right? Did I get that right? How's my math this morning? My arithmetic, am I doing okay? Sometimes I get focusing on the concept and I blow the addition. So that's one way to do it. We can use Venn diagrams. So if you're kind of a visual thinker, just lay out the regions and that's going to work. The formula method really does the same thing, right? We just have to remember, oh yeah, probability of A union B. Make this a little bit thicker. A union B is equal to the probability of A plus the probability of B minus the probability of A intersect B. So if you can remember that, and then now we can just plug things in. You'll see that we end up doing really the same arithmetic. Probability of A union B, 0.7. Probability of A, 0.35. Probability of B, well, that's what we're looking for, minus the probability A intersect B, which is 0.15. So notice it's 0.35 minus 0.15. That's how we came up with this 0.2. So we subtract those, we get our 0.20 plus probability of B. And then, okay, algebra now, we have to subtract 0.20. from both sides to solve for the probability of B, and 0.7 minus 0.2 is 0.5. So we end up with the same answer either way. And just, again, you go with what works. If you can do them both, maybe practicing, and then just know yourself. Are you good at remembering formulas? If you are, then that might be the way that you go with it. Are you good at sort of the algebra? This one, we're doing the same sort of arithmetic, but it's less algebraic. It's less abstract. It's a little bit more concrete. However, some of us have problems maybe with the geometry and putting things. We each do things a little bit differently, and we have our different strengths in different areas. And that's what makes a diverse society so powerful, right? Because we can think differently and stuff. So find the way that sort of, where's your power? Try to develop the other, I guess, so that you can do both. But don't worry about is, again, if you can do one, either way will work. And that's why in the math we show you multiple ways to do really the same thing oftentimes, so that you have a choice and that you could build up, because they use the brain, our thinking, in different ways. And we have different maps up there, depending on what we've done. So far, so good? Okay. So there's some problems like that. This is question 24, but I changed the numbers a bit. So if you go to 24, you'll see the same basic question with different values, different numbers. So you can go ahead and work it. Oops. I have to delete this. I'm not sure I want to keep. Oh, anyway, so here's another one. Again, we're kind of in the place where we're going. We're into like exam review, so we're using some of our review time right now because this is same thing, right? And it'll get you into the homework, and that's what these last sections are very connected to what's going to be on the exam. Okay, so question 25 from the exam review. According to the Weather Service, there is a 65% chance of rain in Portland and a 20% chance in rain in Tempe. There's also a 5% chance that it will rain in both cities. Well, what's the question? Oh, there. Let's take this situation and do a Venn diagram with it. So actually, that's the first question. Fill it out. So I did a little bit. So we call one of these Portland, one of them Tempe. And again, it's up to us which one we want to call which. I'll just do P and T over here. When we fill out a Venn diagram, if we can figure out that middle piece first, it's easier rather than filling in and erasing and doing the subtraction. So there's a 5% here, and I'll show you, I like to work with percentages, so I'm going to list that as 5% rather than as 0.05. It clicks a little bit, realizing everything is 100%. And then I can come back here. Okay, there's the probability that it does it in both. In Tempe, I've got a 20% chance, but remember, I've already accounted for 5%, so how much is in the region that's only Tempe? It'll only rain in Tempe. That's a 15% chance. And then it will only rain in Portland. 65 minus 5 is going to be a 60% chance. Now we have everything we need to figure out what's the probability it rains in both cities, and we're not going to double count this. Okay. So again, we'll show the formula method. You basically double count and then you subtract. This one, I said, I don't even have to worry about it. I just 60 plus 5 plus 15. Okay, 60 plus 5 plus 15, 65, 70, 80. So, well, let's get to the question, I guess. Oops. What is the probability it will rain in neither of the two cities? Okay, so we didn't even know what the question was, but we know the probability of P union T that it rains in either, oh, let's put, interesting, is going to be 80%. So that it rains in either Portland, Tempe, or both. What would be the probability that it will rain in neither of the two cities? 100% minus the 80%. That's going to be 20%. And you could see if you filled in this, we would have had 20% out here as being no rain, right? That gives us our total of 100. So this would be like probability of A union T not. Maybe the not should be inside, but anyway, that it doesn't rain. We good so far? Okay. Let's see, what's the next one? What is the probability that it will rain in exactly one of the two cities? Now this is where this is actually a little bit better than, so it will rain either in Portland or Tempe, but not in both, right? We don't want to count this. We want to count this and this. The Venn diagram in this case was so much better than trying to set up the formula, because the formula, we would have had to do another calculation really to get that. Because we don't want to count it twice. We don't even want to count it once. So 60 and 15, that's going to be, oops, now it's doing it. Is going to be the 60% plus the 15%. That's going to give us 75%. And again, in the answers in WebAssign, they may want you to put 0.75. On an exam, I'll accept 0.75, 3/4, 75%, whichever works best for you. Okay. There's 3 different ways to write a probability. And we go, yes, sir. That's, yeah, that's sloppy. I was looking at it, looked kind of sloppy. Let's 60%. No, well, it's the total. So that's just for this portion of the Portland. It's not the total Portland circle. So it's just this part without the 5%. So